The purpose of this video is to show how to, with a series of cash flows, compute the net present value and also the internal rate of return. You can do this in both Excel or Google Sheets, and it's pretty much the same in both places. So I'll be doing this video in Excel, but you can apply this information to Google Sheets as well. Let's start by building a series of cash flows so that we can calculate the values. Let's assume that we had an investment where we would pay $3,500 today. And then over the next 4 years, so here's years 1, 2, 3, and 4, but over the next 4 years we would receive $1,000 back. And the question we might want to ask is, what is the net present value and the internal rate of return? Before we can calculate the net present value, we've got to understand what is our required rate of return. In other words, what kind of return do we need? And we really need to think about this, because if we were borrowing money to make this investment, we would obviously need to get back a higher rate of return than the amount that we spent to borrow the money. So let's assume for a minute that we need 7% to make this work. So I can calculate the present value of each of these cash flows if we assume that we need 7%. So I'm going to go ahead and put an interest rate up here. So that interest rate is my required rate of return. And we can now use this to compute internal rate of return and also the net present value. Now the net present value formula, which is built into Excel, is NPV, and we're going to go ahead and fill this in. So I need NPV parenthesis, and then the first thing that it's looking for is the interest rate. So I'll go ahead and click on my interest rate and put in a comma. And now it wants a range of values. Now the funny thing about NPV is I cannot just select this whole range, because it does not handle the value of the cash flow for today. So what it will do is I'm going to start with year 1 and go through year 4. And the NPV formula will take the cash flow that's at the end of year 1, and it will go ahead and assign the present value to it and the cash flow at the end of year 2, etc., and get the present value and then add it all together. And the problem is that it doesn't handle the cash flow today, because if I included it, it would think that that cash flow was happening a year from today. But the value of $1 today is $1, so I can go ahead and just tack that cash flow onto the end here. So basically my formula is the net present value given the interest rate, which is in F2, and my range of cash flows starting in year 1, so ignoring the cash flow that's happening today, or in year 0, and then when I finish my formula, I just go ahead and add that initial cash flow back in. And ooh, that came out as a giant percent. Let's change the format of that number back to general. And since we're dealing with dollars, we'll get rid of some decimal places. So here we have a net present value of $112. And what that's telling me is that if I need 7% interest as a return on this investment, it's not going to happen, and that this is a bad investment. Let's go ahead and calculate the internal rate of return and see what it is. So I can do equal to IRR and then open a parenthesis. So the confusing thing here is that the NPV formula works one way and the internal rate of return formula works a different way. And the IRR formula actually works the way you would expect the NPV to work as well, which is I just select the whole range of cash flows. And now I'm going to close my parentheses and hit enter. And let's go ahead and increase the number of decimal places on this one as well, so we can see that the actual rate of return that this series of cash flows is going to produce is 5.5%. Let's assume for a minute, just to demonstrate how a net present value works, that our required rate of return was actually only 5%. So I'm going to change my interest rate here in F2, and notice that when I change the interest rate to 5%, that the net present value is now positive. What that's saying is that if we needed 5%, this would be an okay investment. But if we need something more than 5.5%, then obviously this isn't going to cut it.